This video will cover notes on quadratic functions in factored form. On your notes, I want you to box or highlight factored form so that you can easily see that that's the form that we're talking about. So recall that we've learned two other forms, which were the standard form and the vertex form of a quadratic function. So now we're going to learn factored form. Now we've already talked about factoring quadratics before, so what we're given, if we're given a quadratic function in factored form, it's already factored for us. So looking at the first example, notice that this quadratic, first of all, you don't see x squared, but if you were to multiply x by x, you would end up getting x squared. So this is already factored for us, and being already factored, it allows us to find something really easy. So just like in vertex form, we could easily see the vertex. What factored form allows us to see really easily are the x-intercepts, and I'll show you how. So for the first example, we're going to find the x-intercepts, which recall that means when y is equal to 0. So if I plug 0 in for y, then we get this. And notice that when we solved by factoring in our last unit, that's exactly what we're doing here. If you're equaling to 0, then you take each of your factors, which each of my factors here, I have 3 of them, would be set equal to 0. So now I'm going to set 0 equal to 2, 0 is equal to x minus 3, and 0 is equal to x plus 1. And then you solve each of those equations. Now 0 doesn't equal 2, so we don't have to worry about that one. There's no x value there, so that will not count. 0 equal x minus 3 when x is 3, and 0 will equal x plus 1 when x is equal to negative 1. Now, those are actually not my final answers because the question asked for the x-intercepts. That means the question wants a point. And so I need to write this as the point 3, 0 and the point negative 1, 0. That is my answer for the x-intercepts. Now I'm going to go ahead and graph those on my graph. So I have the point 3, 0 and negative 1, 0. Now, neither of these are my vertex, okay? So remember the vertex is going to be on the axis of symmetry. Now, when we're in factored form, we don't have an equation for the axis of symmetry. So what we do is we look at the middle point between the two points, which in this case would be if I go 2 points this way and 2 steps this way, then we meet right in the middle at x equals 1. Okay, so that's my axis of symmetry, which I'm going to call AOS, is x equals 1. Okay, now another point that we've been finding a lot is the y-intercept. So I'm actually going to go back to the first part and find the y-intercept. So remember the y-intercept is when x is equal to 0. So I'm going to now replace every x with 0 and leave y alone. So we get 2 times 0 minus 3. And we have another x, so we just plug in 0 again for x, 0 plus 1. So this would be 2 times negative 3 times 1, which would be negative 6. Again, make sure you write the y-intercept as a point, so that's 0, negative 6. And we can add that to our graph. Now, please don't mistake the y-intercept with the vertex. Sometimes it is the vertex, but a lot of times it's not. And notice here that this y-intercept is not on the axis of symmetry. So that means that that is not the vertex. Now, I can find another point using the axis of symmetry. So the vertex is, not the vertex, the y-intercept is 1 point away from the axis of symmetry. So if we go another step away, then we have another point on our graph. So we now actually have 4 points on our graph. However, we cannot finish because we actually don't know where the vertex is. So we know that the vertex is going to be on this green axis of symmetry, but we don't know exactly. It could be here, it could be here, it could be here. We don't really know where that vertex is. So with factored form, we're actually typically going to be finding 5 points instead of 3 because we need to find that vertex. So again, you are not done until you have found the exact vertex. You cannot guess. So the vertex, remember, is going to be on that axis of symmetry. So we actually already have half of the vertex, which is x equals 1. So since we know axis of symmetry, x is 1, then what we do is we plug that 1 into our equation, back up at the top. We plug in 1 for x so that we can find the y value of the vertex. So that would be 2 times 1 minus 3 times 1 plus 1. So then that would be 2 times negative 2 times 2, which would be negative 8. Now be careful here. See what I plugged in? I plugged in 1, and I got out negative 8. So my point is 1, negative 8. That is the vertex. All right, and you can see that lies on that axis of symmetry. So 1, negative 8 is here. Now you have a good parabola. Okay? Now, in these notes, we actually have 2 examples of each type of problem. So if you look at example 2, we have another example, and what we're going to do is I'm just going to do the first example of each type of problem in the video, and then we're going to do the second example of each type of problem in class, next class. All right, so I'm actually going to skip example 2, but we're going to do that in class. So now skip down to example 3. There's actually only one like this. So what we're going to talk about is if I'm not graphing, and I know the x-intercepts of a parabola, okay, are 3, 0, and 11, 0. So that means if I were to graph 3, 0, and 11, 0, it would look something like this. Okay, my x-intercept there, x-intercept there. So then my axis of symmetry would be somewhere in the middle. Now, this one's still fairly easy, but what I wanted to show here is there is a formula that you can use to find. If you're looking for directly in the middle of 3 and 11, then what you're looking for is really the average of the x-intercepts. So instead of counting towards the middle, then you can just average. So our 2 x-intercepts are 3 and 11, and then when you average, there's 2 of them, so we divide by 2. So this is just 14 divided by 2, so the x-coordinate of our vertex is actually at 7. Okay, so that's an easy way to find the axis of symmetry if you know the x-intercepts. Okay, so now this is a shaded box. This is important. The factored form for a quadratic function will look like this. All right, so this is our third format. This is what the general equation is going to look like. Now notice that R1 and R2, those are our x-intercepts. Okay, so we use the R to show for the x-intercepts. And the reason we use an R is another word for x-intercept is a root. Okay, it's called a root, so we use R for root. The x-intercepts are going to be root 1, 0, and root 2, 0. Those are the x-intercepts. And then the x-coordinate of the vertex is the average. So that would be the 2 roots added divided by 2. If you want to put in that that's the average, you can. All right, so that is all the information we can pull from the factored form of a quadratic function. All right, so like I said, we skipped example 2. So now we're going to go to example, it should be example 4 here. All right, so we have 2 parts for example 4. So we're only going to do the first one, then we're going to do the second one in class. All right, so it says to find the x and y intercepts and the vertex of each graph. Include at least 5 specific points in your graph and sketch as you go. All right, so the first thing that we're going to do is this is factored. So we're going to first find, when you're in factored form, you're going to find the x-intercepts. So that is, we're going to set this equation equal to 0. So we have 1/4 x times x minus 4. Now, notice we don't have 2 sets of parentheses. A lot of times we have 2 sets, but this one does not. But we still have 2 factors. The 1/4 x is a factor, and x minus 4 is a factor. So now we're going to set both of these equal to 0. And really, if I have 1/4 x equaling 0, what that means is that's going to be 0 when x is 0. Because 1/4 times 0 is going to be 0. Then x minus 4 equaling 0 is going to occur when x is 4. So I have 2 x-intercepts, and the points are 0, 0, and 0.40. Now, if you ever have the origin as an x-intercept, then that means that's also your y-intercept, okay? So that's just kind of a key if you're looking for the y-intercept. You don't have to calculate everything. That's also going to be your y-intercept, okay? So now you actually only know 2 points. So we know the point 0, 0, which is both an x and a y-intercept, and the point 40. So if we were to calculate the y-intercept, we'd still just get 0, 0. So we only have 2 points there. All right, so now what we want to do is find the axis of symmetry. So step 2 is the axis of symmetry, which is right in between 0 and 4. That's easy. That's just x equals 2. So then draw your axis of symmetry at x equals 2. And now we have to figure out what point goes on that line. So that's step 3, is to find the vertex. So you're taking this x value of the axis of symmetry and you're plugging it into the equation. So that's 1/4, so y equals 1/4 times x is 2 times, what was it, x minus 4, so that would be 2 minus 4. So then this would be 1/4 times 2 times -2, which would be, when we calculate, would be -1. So the x was 2 and the y is -1, and that is our vertex. So now graph 2, -1, which is here. Now, I do want us to actually find 5 points this time, because these 3 points, this is a very wide parabola. I still want to kind of see a better shape here. So it says to find at least 5 specific points. So to find another point, we're just going to plug in some other value. Now notice that we're going to be dividing by 4. And notice that from my vertex to my next point, we skipped 2 steps. So what I'm going to do is I'm going to skip 2 steps again. I'm going to calculate when x is 6. Okay, so this is just in order to find another point. So step 4, I'm going to find another point. Now, if I did not, if my y-intercept had not been 0, 0, if my y-intercept had been something different than 0, 0, we would not have to do this last step. Okay, so find another point. We're going to try x equals 6. So if I try x equals 6, then we get y equals 1/4 times 6 times 6 minus 4. Let's see if that works out for us. So that's 1/4 times 6 times 2. 6 times 2 is 12. 12 divided by 4 is 3. So yes, that works. So we have the point 6, 3. So now we can add that point into my graph, 6, 3. And then using my axis of symmetry, that's 4 steps away. So go 4 steps the other direction. And now you can graph your parabola. So you get a much better picture than had you just stuck with the original 3 points. Okay, so like I said originally, example 2 we're going to do in class. So I want us to skip to the last example. So just like we did with vertex form, our last thing that we're going to do is take a graph and write the equation from the graph. So we have here our nice handy-dandy points, which are very important. So we're going to start with the factored form. Now the reason we know it's starting in factored form is, notice on example A, if this is the vertex, notice our vertex is not a pretty point. They don't give me the vertex, so I'm not going to use vertex form. But notice they do give me my pretty points are x-intercepts. So that means if my x-intercepts are given, we're going to use factored form. So we're going to start off with y equals a times x minus root 1 times x minus root 2. That's just the form that we use with factored form. Now, remember, we're given the x-intercept, so my second step is to find those intercepts. So the first one's -5, 0, and the second one is 2, 0. And so this would be like root 1 and root 2. All right, step 3. Step 3, what I would do is you're trying to fill in this equation. So we know root 1 and root 2. I'm going to put that in red. So I know root 1 and root 2. And just like with factored vertex form, I want to figure out what this a is. So what I'm going to do is I'm going to try to figure out values for x and y. So that's just some other point. So what we're going to do, the easiest point to find is the y-intercept. So we're going to find the y-intercept, which they give me is here. So that's 0, 3. So what that allows me to give for the equation is x and y. So now I have all those components. Now I just need my a. So for step 4, we're going to calculate a, just like vertex form, just using the factored form. So the y is 3 equals, a is what we were looking for, x is 0, minus root 1 is negative 5, so that will become plus 5. Then x minus root 2, which is 2. Oh, and actually, the x there, I accidentally wrote x again, but we are using our x this time as 0. All right, so now we can solve. We have 3 equals a times 5 times negative 2, which really would be negative 10a. And then to solve for a, you would just simply divide by negative 10. So a is negative 3/10. Now we want to put all of that together. So going back to my factored form, we have y equals a, so that's negative 3/10, times x minus root 1, which was minus 5, so that would be plus 5, and x minus root 2, which was 2. And so that is my answer, and we'll do example 2 in class.